Hello students, welcome to my channel. In this video, we will cover top 5 common mistakes some people make while using steam tables. Also, we will understand how to avoid those common mistakes. Here students, note that if we make any small mistake, this can lead to massive error in your calculations related to steam table. Okay students, so it is very important to avoid these 5 common mistakes while using the steam tables. So students, see here, let's see first. We will first list out the what are those 5 common mistakes. So here, see, first mistake is confusing pressure inputs, that is between absolute pressure and gauge pressure. Further, here second is forgetting to convert units, that is bar to MPa, megapascal, bar to megapascal. Okay, then third is using wrong regions, that is saturated versus superheated. Further, skipping interpolation for intermediate values. It is very important, students. Fifth is misinterpreting steam quality calculations. Okay, so let's now see the one by one each mistake and how to avoid them. So here first is confusing gauge pressure with absolute pressure. So here let's see first difference. So here see, absolute pressure includes atmospheric pressure. So as we know here, absolute pressure is the sum of the gauge pressure and atmospheric pressure. So here formula is P absolute is equal to P gauge plus atmospheric pressure, that is 1.013 bar. Okay. So gauge pressure is measured relative to the atmospheric pressure. So example now we will see. So here, if the pressure gauge reads 5 bar gauge, the absolute pressure will be 5 plus 1.013 bar, which is equal to 6.013 bar. Okay, so here this is the example. Further, using 5 bar directly in the steam table would lead to incorrect enthalpy and entropy values. So students, if we have the question and in that it is mentioned as pressure gauge reads the 5 bar, and if we use that 5 bar directly into the steam table, we will get the wrong inputs, sorry, wrong answers, that is enthalpy and entropy related values. So we need to always see what unit, what we have given in the question, that is if it is given as gauge pressure, then we need to convert it into absolute pressure. Okay, so further see how to avoid these mistakes. So always check if the given pressure is absolute or gauge and convert as needed as per the steam table. Steam table. Okay, so further see, skipping interpolation for intermediate values. It is very important, students. Importance, steam table values are typically listed for specific pressure and temperature increments. If your data falls between two values, interpolation is required. So here see, if pressure and temperature values which are in the steam table are given for the specific values, so if your data is lies between those values, then interpolation is required. Say, let's see how it is. For interpolation example we will see now. So here suppose temperature is 17.5 degrees Celsius, falls between 17 degrees Celsius and 18 degrees Celsius. HF is what? So here students, see this, as you can see here in the saturated water and steam temperature tables, as you can see here it is a 17 degrees Celsius temperature and 18 degrees Celsius, and our requirement is at 17.5 degrees Celsius, which lies between 17 and 18 degrees Celsius. So we need to calculate HF value for this particular temperature, that is 17.5 degrees Celsius. So let's see how we can calculate. For that we need to use formula. Okay, so here see, let's let's see, let consider the x is equal to 2 and t and y is equal to hf. So let's use the interpolation formula, which is here y is equal to y1 plus x minus x1 upon x2 minus x1 into y2 minus y1. And now we have put here the values, as you can see here, 17 corresponding to the 17 degrees Celsius. We have here 71.3 HF, okay, 71.3 kilojoule per kg HF, okay, and at 18 degrees Celsius we have here 75.5 HF. Okay, so we had put here values, as you can see here, and after that we got here answer 73.4 kilojoule per kg, which is corresponds to the 17.55 degrees Celsius. So for this, from this interpolation method we have calculated here HF. So at T is equal to 17.5 degrees Celsius, we got here HF is equal to 73.4 kilojoule per kg. So here further see how to avoid mistakes. Learn and practice interpolation or use software when precise values are needed. Okay, so let's see further here. This identifying the region saturated versus superheated. So why this happens? Many users fail to compare the given temperatures with the saturation temperature for the specified pressures. Okay, example, let's see. For P is equal to 1 megapascal, T saturation is equal to 179.91 degrees Celsius. If given T temperature is 150 degrees Celsius, then the state is subcooled. If temperature is 250 degrees Celsius, then it is superheated. Okay, to how to avoid these mistakes, always compare the temperature to the saturation temperature in the table. Okay, so further, ignoring quality X in wet steam calculations, it is also very important, students. Okay, we need to calculate the steam quality. Okay, what is steam quality? X. Quality represents the fraction of steam in a saturated mixture. Here X is equal to 0 for saturated liquid and X is equal to 1 for saturated vapor. So let's see the common error, treating wet steam as fully saturated vapor during calculations. Okay, wet steam always contains some moisture. Okay, so that's why we need to calculate here quality of steam, that is X. Example, given P is equal to 0.1 megapascal, H is equal to 1500 kilojoule per kg. So from the table we got here values. HF is equal to 417.46 kilojoule per kg. HFG is equal to 2258.0 kilojoule per kg. So further quality, steam quality can be, so here we will use the formula to avoid these mistakes, so which is H is equal to HF plus X HFG. So from that we can now calculate X is equal to H is equal to HF plus HFG is equal to, we have put the value and got here X, that is steam quality V is here in this case 0.48. So further how to avoid mistakes, using the formula H is equal to HF plus X HFG for wet steam, we can avoid these common mistakes. So further see here, mixing up units. Okay, it is also very important. Steam tables may use different unit systems. Example, kilopascal, bar, kilo kg per meter cube or meter cube per kg. So confusing between these units leads to significant calculation errors. So it is very important to understand the calculations and to understand the units and unit conversion. So for example problem we see here, if the pressure is given as 100 kilopascal and you accidentally treat it as bar, results will be incorrect. Okay, so how to avoid those mistakes? To avoid those mistakes, always we need to double check the units, and if we need the conversion, then we need to do the conversion of the units as and when required. So here see 1 bar is equal to 100 kilopascal, which is equal to 1 meter cube per kg, which is equal to 1000 kg per meter cube. So let's students now quickly review what we have seen in this video. So we first seen here the we need to avoid the confusion between the gauge pressure and absolute pressure. Secondly, whenever required, we need to use the interpolation to calculate the intermediate values. Also, third is we saw that we need to avoid the misidentifying of the saturated and superheated regions. Fourthly, we seen here the we need to calculate the quality of steam, that is X. Okay, and also we need here in this case we need to do the wet steam calculations by using the formula H is equal to HF plus X HFG. Here X is the steam quality which we need to calculate while using the steam tables as and when required. Also, the fifth one is we need to avoid the mixing up units, that is we need to understand and see the what units we have given, and if required we need to convert the units into the another unit. Okay, so students, in this video we have understood about how to avoid the 5 top common mistakes which some people make while using the steam tables. Thank you students for watching this video. Like, share and comment for this video and subscribe my channel. Thank you.